All right, ladies and gentlemen, this is going to be our next presentation on the atmosphere. So let's get started on this next video. So let's say we were comparing the temperatures on both the surfaces of the moon and the surface of the earth. And let's quickly review. The sun is going to project light rays on both the moon and the earth, and this is going to cause temperature differences both during the day and the night as well as during seasons. So if we were to compare the temperature of the moon over the course of the day, well, on the light side of the moon, it's going to be somewhere around 100 degrees Celsius. And on the dark side at nighttime, it's going to be somewhere around negative 170 degrees Celsius, which is very cold. Now, this is going to be for an average temperature of somewhere around negative 18 degrees Celsius. If we compare this to the Earth, on the Earth, even during the hottest of days it was ever recorded, the temperature was a blistering 71 degrees Celsius, and the coldest temperature was somewhere around negative 89 degrees Celsius for an average temperature of somewhere around 15 degrees Celsius, which is significantly more stable. So the hottest of hot is not as hot as the moon, and the coldest of cold is not as cold as the moon. The temperature is more stable. Well, why is this? Both the Earth and the moon are almost exactly the same distance from the sun, so why do we get this drastic temperature difference where the Earth is so much more stable? Well, this is a result of the atmosphere that exists around our Earth. And the atmosphere has 4 layers: the troposphere, the stratosphere, the mesosphere, and the thermosphere, and we can see them here. And this layer of gas keeps the temperature stable and allows us to exist on the Earth. So the atmosphere really is just that layer of gas that covers the surface of our Earth. And really all an atmosphere is, from a definition standpoint, is a layer of air that surrounds the Earth. So the atmosphere has a couple important things, and it does a bunch of really important things for us to sustain life. The first thing, again, let's review the layers of the atmosphere. So the 4 layers are the one closest to us. We're going to start from the bottom up, so the layer that we live in, which is the troposphere. Then we have the stratosphere, which is the next layer up. Then we get to our mesosphere. And then right at the outskirts of the top edge of our atmosphere into space, well, this is the thermosphere. And the atmosphere is really important for a few reasons. The first reason is it's going to provide protection from ultraviolet radiation, or rays that can be harmful to humans and all life. The other thing, which we just talked about before, is it's providing insulation and stable temperatures for us to live in. And lastly, it's providing the gas for us to breathe, so that way we can go through and breathe in oxygen and survive. Now, if we think about it a little bit more, we can see that the atmosphere has a couple of effects. Well, let's think about this. It's going to affect the weather. It's also going to go through and affect the climate. And lastly, it can affect the temperature, which we've talked about a couple of times now, on our surface. Now, if we're thinking about the scale of the atmosphere compared to the Earth, let's pretend the Earth is this apple. Now, the atmosphere is going to be about, in terms of scale, the thickness of the outer skin of the apple. And if we were thinking about the Earth being the solid, or the core part, the solid mass of Earth is like the core of the apple. So the atmosphere is just like the layer of skin on an apple. And it's very, very thin compared to the rest of Earth. So the atmosphere is actually a very thin section of what we call our home. Now, the composition of the atmosphere consists of a couple of things. Most of the atmosphere is not actually oxygen. 78% is nitrogen. The rest is oxygen, 21%. And then there are also a few miscellaneous gases. The 1% consists of carbon dioxide, methane, ozone, any other gas that we can think of. Argon, xenon, helium, that's in our balloons. That makes up the other 1%. So 78% of our atmosphere is actually nitrogen, 21% oxygen, and then 1% is all other gases that you can think of. So let's say we were thinking about the space, and let's think about we were looking at these layers as if they were put on top of each other. So the troposphere is the layer here where the mountains and the city are. Then we have the stratosphere on top of that. the mesosphere, the thermosphere, and then we can see where the rocket ship is. This is space. And the atmosphere is kept in place because of the gravitational pull of the Earth. Now, if we're thinking about space and we're thinking about the atmosphere first is going to provide protection and a shield from some of the radiation. So during the daytime, the sun is going to project electromagnetic radiation. And what really the atmosphere is doing here is it's creating a boundary or a shield. Some of the radiation is going to get absorbed, but a lot of it's going to get reflected back into space to keep the Earth at a stable temperature and to protect us from ultraviolet radiation. Now, during the nighttime, we're going to see that as some of the radiation goes through and penetrates, what it does is the atmosphere is going to act like a blanket to trap in all the heat that we need to keep us warm at night. So the other thing I want to keep in mind here is as we go up in the atmosphere, the density of the gas molecules is going to go through and decrease. So the troposphere is going to have the highest density of gas molecules. And as we go up subsequent layers, the density is going to go through and decrease. So each layer and the further up and the closer we get to space, the less dense the molecules are going to be. So we can see up here, this layer, we're going to have less molecules, less density. And down in the troposphere, we're going to have the most or more density of molecules here. And we can see in this layer, we're going to have the most amount of gas molecules. And then as we get up by the thermosphere, we're going to have the least amount of molecules. So it's really important to keep in mind that as we go up the atmosphere, the density is going to decrease. Density will go through and decrease. So just as a last diagram to go through and work through this, what we can see is we have two jars here. Now, we can see that this jar here has less gas molecules in it compared to this jar here. So the density of this jar is less, and the density of this jar is more. Now, gravity is going to be consistent amongst both of these jars, but we can see this one here is going to have the lowest pressure because it has less molecules here, and this one's going to have the highest pressure because it has more molecules. Remember, gravity's pulling down on these molecules and they're going through and interacting and pushing on each other. There's more of them on top compared to here, from here compared to here, and we have less pushing down on top of this one. So when we have less dense gas molecules, as we see here, we can see that we're going to have a lower pressure. But if we have a more dense quantity of molecules, we're going to have a higher pressure. It's important to note that as we go up through atmospheric layers, the further and further we get away from the surface of the Earth, the pressure is going to decrease because the density is decreasing. So the first thing I'd like to do is look at the troposphere. So let's delve into the troposphere a little bit so that way we can better understand what's going on. So the first layer that we're going to go into is the troposphere. And the troposphere is about 10 kilometers tall. So about 10 kilometers up in the air, this is where we go through and get to the edge of the troposphere. Now the troposphere is where all life exists, and this is where we breathe our oxygen from. So all animals live here, all of the entire human species lives here, and we really depend on this troposphere for almost everything. Now the troposphere is going to consist of about 75% of all gases in the atmosphere, and this is where all weather occurs. It's also going to be the densest layer. Now, the thing that we have to keep in mind is how the air is going to mix. So the coolest air is going to actually be at the top of the troposphere. So we're going to have cooler, less dense air at the top, and then we're going to have warmer, more dense air closer to the bottom. And this has to do with gravity, and it has to do with how the molecules are packed together in this place. So let's go through and delve into the stratosphere now and look at it in a little more detail. Now, the stratosphere is going to have a really important role, and it's going to be where our jetliners go through and fly. Now, the stratosphere is going to be about 50 kilometers up in the sky, so from the surface to the edge of the stratosphere is going to be about 50 kilometers. And the stratosphere is going to have the reciprocal of what the troposphere does when we're talking about mixing air. So at the top of the stratosphere, because of the way that the light goes through and interacts with the next molecule we're going to talk about, it's warmer at the top and cooler at the bottom. Now there's a really, really important molecule called ozone. And ozone is really, really important for life on Earth. Now ozone is going to consist of 3 oxygen atoms bonded together. 2 of them are double bonded, the other one is single bonded. And ozone, what its main function is going to be is to block ultraviolet radiation from penetrating into the troposphere. And this is going to ensure that we don't get skin cancers and have mutations on our skin. So ozone is really, really important to block ultraviolet light, which is what causes sunburn and skin cancer and prevent us and allow life to prosper. All right, so let's go through and look at the mesosphere in a little more detail now. So in the mesosphere, we're going to have fewer and fewer gas molecules here. And the mesosphere is going to be somewhere around 80 kilometers from the surface of the Earth up to its edge. So we're going to have less and less gas molecules here, and the density of these molecules is going to go through and decrease, just like we've talked about before. So we can see that they're more and more spread out, and because of that, this is going to have a few effects on the human body. So a couple other things about the mesosphere. The temperature is going to be somewhere around negative 90 degrees Celsius. It's going to be very, very cold. Now, it's important to note here that because of the low pressure, this is going to go through and have effects on our body. Now, there is no ozone here to block ultraviolet radiation. So if you were a human in the mesosphere, not only would you be exposed to ultraviolet radiation, but your body, because of the low pressure, your blood would boil at normal temperature, and it would prevent you from being able to survive in the mesosphere. That's why if you travel to the mesosphere, it's really important that you would have to wear some sort of suit. If you've ever seen the Red Bull skydiving video, he actually jumps down very close to the edge of the mesosphere up into the thermosphere, and he wears a special spacesuit so that way he can survive because of the low pressure. Now, the other thing that we want to keep in mind here is this is where meteors are going to go through and burn up in our atmosphere. So the mesosphere plays an important role in protecting us from meteors that will penetrate through the atmosphere and allow them to burn up before they hit the surface of the Earth. All right, and last but not least, let's go through and look at the thermosphere now and try to understand its properties. So the last sphere that we're going to look at here is the thermosphere. And the thermosphere is really, really interesting because the density of molecules here is so low in the thermosphere that a gas molecule can go almost 1 kilometer without colliding into another gas molecule. So the edge of the thermosphere is somewhere about 100 kilometers from the surface of the Earth. There is no real defined edge like I've shown in this picture, but it's somewhere around 100 kilometers. So if we think about this, just like I said before, there's almost no gas molecules here, and it is very, very cold. So there would be about 1 kilometer distance between gas molecules before they would go through and potentially collide. Now, the other cool thing that happens in the thermosphere is we're going to get the aurora borealis, and we can break the thermosphere into separate subspheres. So at the bottom we have the ionosphere, and the ionosphere is where we're going to have ions that are going to become charged in the atmosphere. We can break it down into the magnetosphere, and this is where the aurora borealis occurs, and this is where you see the northern lights, and you can see them flicker and move because of the magnetic field and electromagnetic radiation from the sun interacting in the thermosphere. Now, the last sphere that we're going to talk about, or the last subsphere that we talk about within the thermosphere, well, this is going to be our exosphere. And the exosphere is going to be the edge of space. Now, it's not really defined because we're going to have some particles that just extend a little bit beyond the exosphere. It's kind of just like a fuzzy edge. But this is where we get to the edge of our thermosphere. Now, the last thing that we have to talk about in the atmosphere is greenhouse gases. And greenhouse gases are going to have an effect on our temperature, and they allow us to create a stable, livable temperature on Earth. Now, greenhouse gases that we're going to talk about are, in this case, we're going to have nitrous oxide. We are also going to have carbon dioxide, methane, and then ozone. We've already talked about that. Water vapor can also be part of this. Now, greenhouse gases are going to make up less than 1% of all the gases in the atmosphere. And we can see that they're going to mostly be contained closer to the bottom of the atmosphere. Now, the sun is going to allow for electromagnetic radiation and sunlight to go through and penetrate through our atmosphere. And what this is going to do is interact with these greenhouse gases. Now, what ends up happening is when electromagnetic radiation comes in contact with these greenhouse gases, it's going to excite them and cause them to be reflected back and forth amongst each of the gas molecules. Now, some of the light is going to get reflected back into space, but some of it gets reflected back onto the surface of Earth, and it keeps it trapped. And the way we can kind of think about this is, if we think about our atmosphere and sunlight coming down, well, it's going to get reflected off the surface of the Earth. It's going to excite our greenhouse gases and then get reflected back on the surface. So this is going to continue to cause the surface of the Earth to heat up. Now, if we were thinking about this on the moon, well, the moon doesn't have an atmosphere. So all of the electromagnetic radiation that goes through and hits the moon gets reflected back off into space, and the moon's not going to have any heat and any sunlight really that's trapped within its boundaries. So greenhouse gases are really important because, well, if we get too many greenhouse gases and we build up too much carbon dioxide, methane, nitrous oxide, or ozone, what it can cause is the atmosphere to overheat, and then the temperatures can go through and rise on the surface of the Earth. All right, so did you guys learn? Well, did you learn a couple of things? Did you guys learn what the atmosphere is? Did you guys learn why the atmosphere is important? Did you guys learn how the Earth compares to the moon in terms of the Earth having an atmosphere and its temperatures, and the moon not having an atmosphere and the temperatures? Did you guys learn the layers of the atmosphere? And did you guys learn how greenhouse gases affect temperature on the surface of the Earth? This is going to be the end of the video. I hope you guys enjoyed this and found it useful.